lately, every presentation I've given, maybe the last 5 years, has started with the word weather, so that's what I'm going to be talking about today. Weather data, site variability, and kind of follow up on Josh's presentation on adaptive management and how weather variability can be used in your planning. We were asked to use this model in our presentation, so when I was asked to put a weather presentation together, I started with this model. And what I always do is just look at what I'm given and ask myself, where does weather factor in? I stopped drawing circles. I've given presentations for it anyway. So that wasn't really working. So I simplified my presentation. I'm going to be talking about weather variability and how it relates to the planning process, both upfront planning, adaptive management, and reassessment. Those of you that have known me for a while know I'm uncomfortable with any level of simplification, so I'm going to abandon this model and go to one that still has all the arrows and boxes, just so that I can keep comfortable. But I'm going to pretty much go through the same model structure that Josh went through when he was talking about adaptive management, discuss some of the important aspects of weather variability, and hopefully get people to think about this in the entire planning process and how that knowledge might be used to enhance planning and success. Just a few definitions related to parts of the EVIPID model I'm not really going to talk about. There's a lot of interchange between this particularly use of the terms weather and climate. Everyone sort of understands what microclimate is. Weather tools have been used in restoration planning for a long time, but mostly from the aspect of plant material selection. Everyone's seen maps like these, and most seeding guides are based on known relationships between mature species, mature plant communities, and gross climatological variability across the landscape. Climatological information is mostly useful for plant material selection, but it's not really useful except as a baseline for restoration or vegetation planning, because the conditions required to establish a plant in a severely disturbed situation are much more restrictive than can be found in a gross kind of weather or climate map. The other thing I'm not going to talk too much about specifically is microclimate and seedbed microclimate that I usually talk about, because that's where my research interest is. The microclimate is affected by all of the weather inputs, but different soils in particular, different types of plant cover, whether they're weeds or a mature native community, all affect what the seeds are seeing, and that's the time when you're trying to adjust the trajectory of a plant community. Most of our seedbed preparation and seeding treatments are designed to improve the seedbed and actually to optimize it for creating safe sites for the species of interest, perhaps to reduce safe sites for things like introduced annual weeds. One problem about our microclimatic management and all the treatments that were in the list is they're pretty much designed to optimize whatever you end up getting, but they're generally prescriptive. We usually don't take advantage of our knowledge of weather and climate variability. We just do things that on average are going to improve our likelihood of success. What I'm going to talk about for the rest of this talk is variability in the inputs to microclimate. Weather is what actually happens, as opposed to climate is what you're faced with after a fire when you're implementing a burn rehab plan or contemplating just generic restoration. First thing about weather is it's highly variable. The other thing about rangelands is they're generally arid or semi-arid, which everyone knows means usually dry. This is a record I use a lot for Boise, Idaho. This is total annual precipitation. It's about a 300 millimeter preset zone from 1941 to 2009. And everyone knows that if you try something in one of these years, you're going to be less successful perhaps than in one of these years. The other thing about weather is events that affect progress of seeds through their life cycle can be very short term, especially the negative ones. And the shorter time scale you're looking at, the more highly variable weather is. If you're looking just at spring weather, this is March, April, and May, sort of spring weather variability over the same time period. It has about twice the inherent variability of the annual weather. And if you look at an individual month, it has twice that variability. So if you see a key restoration month in the Great Basin like May, things are warming up enough for things to get going. This is the kind of variability you can expect, and one of these Mays can really set you back, even if you have good average weather conditions. So going back to this model, I'm just going to go through the adaptive management framework and just discuss a few things for each of these steps that are important to consider when you're doing planning. First thing above all, try to find some weather collaborators. That always helps out up front. Hopefully our EBIPM website will provide the type of information you need as we develop some tools over this next half a year or so. The major thing in your setting goals and objectives, and it was touched on earlier, is we have to get out of the mode of putting together a plan that's only going to be implemented one time, that's going to have a higher probability of success than a lesser plan. We need to start establishing goals that are maybe 10-year goals that acknowledge the fact that there are going to be partial successes and failures, and we might, or most certainly, are going to have to do more than one thing in more than 1 year. And even if we do get success, we're going to have to follow that up with management. But I see post-restoration management just being an extension of the fact that you have very high variability and you have to manage for that variability. Whereas weather data, right now it's all over the place. Working with some people at the Western Regional Climate Center to get one-stop shopping for weather data. But most of the data sources are online. Unfortunately, there aren't as many weather records as you'd think in the Great Basin or in the West in general. The West is complex topography that affects weather and microclimate. But most of the information now is available, and if you're only interested in one site, it's fairly efficient to find weather. This is what we call Class 1 Met sites for the Great Basin. Those are the hourly weather records like you get at an airport. It's actually a lot of co-op data that was from NOAA, the NOAA site. This is also off the NOAA site. These are co-op records. For purposes of planning that we do in restoration, these records are somewhat flakier than the full Met sites. Someone goes out once a day, measures total precip for the day and a min-max temperature thermometer, but they're all over the place, and daily records are usually adequate for the kind of things we do. There's a bunch of really good weather records depending upon where you are. I do a lot of stuff in the Snake River Plain of Idaho. Bureau of Reclamation has an agri-met network that's as high quality as NOAA's Class 1 stations. There's a lot of seasonal data that's useful for different purposes. This is from the RAWS site, I guess. Western Regional Climate Center manages some of this. BLM deploys these mostly for fire weather, but they're very useful, particularly if you're out in the middle of nowhere and there's nothing better nearby. The Western Regional Climate Center has developed a lot of tools for people that are sort of one-stop shopping, but it's still mostly climatological. It's mostly average information and not really the kind of stuff you can use operationally or to evaluate variability, which is what we're really talking about in terms of adaptive management. One of the things they do, and at the NRCS ESD workshop on Saturday and throughout the week, there are people who have tools, or essentially with a spreadsheet, taking these weather records and generating this type of information, which is where you start when you get a weather data set for restoration planning. I put 10 degrees in here as a line because that's when things really start moving in terms of growth. This is also the Boise weather record. It's important to look at the seasonal patterns of these different weather parameters in addition to variability, because depending upon what's important at that site and what processes are involved, you want to be looking at weather and weather variability during the period that things are happening that are affecting your potential success. For instance, a lot of times cheatgrass production and its subsequent competitive ability is linked to conditions in the late fall. When you get into these rising temperature, that's about when you're also losing soil water. That's an important establishment period that has to be favorable to be successful. But things when not much is growing except maybe cheatgrass in the winter, that's really important for soil moisture storage during this heat and drought period. So when you're looking at summarizing weather data, it's insufficient to use yearly averages. It's insufficient to look at just what's happening in the spring. You really have to think about what's going on phenologically and developmentally, and look at the variability using restoration-specific weather and climate indices. The next thing you can do immediately is take your data. I ranked all the Boise records from high to low just to get a sense of what the baseline is. Usually the only information you get is what's the average. Half the time you're above it, half the time you're below it. What kind of variability do you expect? We did a synthesis of rangeland seeding literature for NRCS. Pretty much every seeding paper that said there was some success in the study noted that it was average or above average precipitation. That implies there's some kind of threshold where you shouldn't really expect that kind of success, otherwise these people would have been able to publish their data. The other thing to see is this is that spring period. You can see it's somewhat correlated, but it's not really matching that. If you're doing a ranking of your site to get a sense of what the expectations are for variability, you need to rank it based on more than just crude climatological information. The next thing, as far as developing a plan, I mentioned before, I think it's important to plan for partial success or non-success. I don't know how many tours I've been on over the years where you're looking at what is being described as restoration success. You can see seedlings coming up. You can also see cheatgrass coming back in. If you write an EA for restoration plan with BLM, you might only describe what you're going to do in year one. We need to start thinking longer term and ask ourselves, depending upon what we get in year one, what kind of treatments are we going to do in year two or year three, based on just contingencies of what happens and what kind of weather year we get. We talked about adaptive management and the need for monitoring and assessment throughout the process. That means establishing control plots and monitoring for much longer than we normally do. And then as far as putting in a sort of mini experiments to keep track of what's successful and what's not, we really need to consider multiple year treatments, including multiple years where you do the initial establishment the same way. This turns out to be very important when you're talking with stakeholders or your boss. They need to know that these are probabilities of success and there's variability, so that you don't end up getting judged on what happens in a particular year when it may not have anything to do with you, something failed. Another thing we need to start thinking about is maybe more proactive planning in areas that we know burn frequently, because after fires on federal land, typically a fire rehab plan has to be in place within 2 weeks, and that's insufficient to really survey meteorological data and things like that. So having proactive plans is important. When you're actually implementing the plan, some of this might be outside the reach of people. I know BLM might deploy RAS stations on large fires, but you need to consider on-site weather data. And when you're monitoring, it's really insufficient to go in and just say, was it successful or not at some early summer stage. We need to start thinking about what's going on in the seed bed and looking at our timing of weather variables. and asking ourselves what's really going on and at what stage are things getting truncated or resulting in partial success. The other thing is a lot of the experimental setup that was described earlier is sort of a traditional ANOVA approach. We need to start thinking about looking at success and failure, treating weather as a continuous variable, or at least put it in the context of that ranking of years. We talked a lot this week about state transition models. This is kind of a stylized model for native sagebrush, bunchgrass burning, maybe going to weeds, maybe going back if there isn't a seed source, various assisted succession scenarios. Just important when you're evaluating to put it in the context. Maybe it was a pretty good weather year and all of these things are possible. Maybe it was this kind of year and there really wasn't anything possible. That's what we've talked about, assessing success and failure relative to what actually happened. So since we're winding up, I just wanted to summarize some of the main ideas. To utilize weather information, we have to have much longer-term planning horizons. We have to have contingencies for what we would do should things happen in a certain way. That can get fairly complicated, but especially if you have to write an EA to implement your plan, if it's not in the EA, you're going to be constrained later. A lot of the NEPA process associated with emergency fire rehab is in place ahead of time, but you can only implement your plan in the first couple of years. And we talked about weighing success and failure by weather indices, replication, and really I think in order to use these tools it's going to take a little change in the logistics of how we do restoration and fire rehab planning. We need to become advocates for using this kind of information and accepting alternative logistics for our approach. Just a couple minutes on what's on the horizon. There's a lot of work going on with global climate models and climate change. Those are the same models that can be used for seasonal forecasting of what's going to happen in the spring if you're doing a fall planting. This type of information would be very useful, and they're starting to disaggregate these models to a spatial scale that's useful for active management. If it didn't burn, you might be able to say this isn't a year to do anything, or this is a year I want to spend $250 on some forb seeds because we have a good chance of success. Or if it's a marginal year or it burned and you have to stabilize the soil, you might be looking at an adaptive or assisted succession scenario and maybe planting something that's easier to establish and deal with diversity issues in a good year. I'm working with the Western Regional Climate Center to get one-stop shopping for this weather data, and we have some gridded data products that are going to make it easier to estimate what's happening at your location. We're trying to convert this to a format that can be accessible off the EBIPM webpage, so you can just type in your latitude, longitude, and not only get a 30-year historical scenario for that site, but get some derived value-added products that give you restoration-specific weather indices and climatologies. There's also work with USGS and BLM on the landscape treatment data library. Some of this data is now becoming available for meta-analysis, and we're hoping to use our weather and climate database to retrospectively evaluate these restoration-specific weather indices relative to success and failure of mostly BLM plantings. And of course, anything we develop will be available, or all this other stuff is available off the EBIPM website.